Assalamu alaikum students, this is Farwa Batool, your O-level computer science instructor, and welcome to another video. Since we are talking about trace tables and we have seen some of the examples of flow charts, how we can dry run a flow chart and fill the trace table accordingly. Now in this example or in this activity 7.13, we are going to see that how we can dry run pseudocode and how we can fill the trace table according to it. Now, look at the example over here. Activity 7.13 says that use the trace table below and the test data. Look at your test data 4, 8, 19, 17, 3, 11, 6, 1, 13, 9. These are the 10 integer values that are given to us as test data to test the pseudocode. To record a dry run of the pseudocode, we have to dry run the pseudocode and then we have to fill the trace table. It means whenever we feel the changes in the values of the variables, we will record them in this particular table. Now, look at here in your trace table, there are variables A, B, C, X, and there is output for the pseudocode. Now, look at the pseudocode on your left hand side. Let's quickly see that. Okay, the first three lines are basically the variable initialization. In variable A, they have put a value 0, variable B is initiated with 0, and variable C is initiated with 100. So look at this, in the trace table, it is already written in column A that it is or it has a value 0 in it, variable B has a value 0 in it, and variable C has a value 100 in it. Now, after that, there is an output message in your pseudocode. This output says that enter your 10 values. It means you are asking the user to enter 10 numbers or 10 integer values. Now, what will you do? There is a repeat until loop if you see in your pseudocode. This repeat until loop is going to work on all of those values one by one. The first thing here is the input statement. The input statement is using a variable x to store the test data. Remember that whenever user inputs a value, it will be stored in the variable x. So all of the 10 values will be stored one by one in this variable. Now, there are two if conditions. The first if condition is comparing the value of variable x or the test data with variable b. And the next condition is comparing the value of test data with variable C. These are two if statements. And according to the result, we will be performing these then statements. We will go to then if the condition is true. Otherwise, we will go to the next condition or next if statement. If the condition is false, we will not execute then statement. Now, at the end of both the statements, if conditions, now we have here an assignment operator. This says that A is incremented or A is going to store a value that is A plus 1. It is very simple that whatever the value of A is, you will increment it or you will add 1 to it and store it again in variable A. This is increment, what we call. The next is you have to check for the until condition if it is true or not. Remember, if the until condition is false, you will continue with the loop and continue with the next iteration. But if this condition A equals to 10 is true, then you will go out of your loop. This is how a repeat until loop works, that whenever the condition becomes true, the exit condition, you go out of your loop. And if it is false, then you will be in the loop. Now, after this until condition, let's suppose it is satisfied. Then you have the next statement, which is an output statement. You will output the two values on the display. The first is the value of variable b. Whatever is stored in variable b will be shown on the screen, and whatever is stored in variable c, the integer value, will be shown on your screen. Now, let me quickly tell you the purpose of this pseudocode. It is just the same as we did in the previous example where we worked on a flowchart. Now, what is this? You have 10 numbers and you have to find out the largest out of those 10 numbers and the smallest number out of those 10 integer values that the user is giving us, or in this example, that we are considering as our test data. So, if you see the test data here, the largest value that is given to us is 19 and the smallest value is 1. So remember that if variable b, that is storing the largest number, will give us a result 19 at the end of pseudocode, and variable c, which is storing the smallest value, is giving us 1 at the output of the pseudocode, then we can say that this pseudocode is designed perfectly. It is doing its job. But if there is some other value in variable c other than 19, or in variable b, if there is other than 19 value, and in variable c if there is other than 1 at the end of your pseudocode dry run, then you can say that there is some error in your pseudocode, which is basically the purpose of your trace table, that you can also detect errors in your algorithms. Now quickly dry run this. I have talked a lot about this. Now quickly dry run and fill the trace table accordingly. Okay, so I have cleaned everything for you. Let's start with the working. ABC has initial value 0, 0, 100. Now let's suppose the user gives us 10 values, that is your test data, and we go inside the repeat until loop. This is your first iteration. Let's start recording it. For the first time, what will happen? Input x. X is going to store the first value of your test data, which is 4. If you see here, the first value is 4. 4 will be stored in the variable x as an input. Now, you will compare the value of x, which is 4, with the value in variable b, which is 0, as b is initiated with 0. 4 is greater than 0, which is a true condition. Remember, when the condition is true, you will execute then statement. So then statement says that store the value of x, which is 4, in variable b. And remember that whenever there is a change in the values of the variables, you will be recording them in the trace table. So first of all, put 4 in variable x, because 4 is the first value stored in this variable, and then since the value of variable b is changed, so also put 4 in that column of variable b. Quickly see the next condition. X has a value 4, x is less than c. C has a value 0 initially. 4 is less than 0. Is it true? No, 4 is not less than 0. Oh, sorry. C is initiated with 100, not 0. Now the condition becomes true because 4 is yes, it is less than 100. Since the condition is true, you will go and execute then statement, which says that put the value of x, which is 4, in variable c and also record it in your trace table. Now, next is you have to increment the value of a. So the variable a is initiated with 0. 0 plus 1 is going to be 1. So the new value of variable a is 1. Now we are going to check for the until condition, if it is true or not. It's very clear that value of variable a is 1. It's not 10. So this condition becomes false. And I already mentioned that if the until condition is false, you have to go back to the loop again and do the next iteration, which is number 2. Now, look at the second value of your test data, which is 8. Let's put 8 in variable x. This is your second iteration. Now, put the value of variable x in your trace table, which is 8. Now, let's do for 8. If 8 is greater than the value in variable b. Now, look at the last modified value or stored value in variable b, which is 4. in the previous iteration. So you have to compare 8 with 4. Is 8 greater than 4? It's a true statement or true condition. When the condition is true, go to the then statement and execute it. B will store a value of x, which is 8 this time. Now there is a change in variable B. You have to store or write it in the trace table also. Next, is 8 less than the value in variable C, which is 4. Look at the last modified value of variable C, which is 4. 8 is less than 4, which is false. Since the condition is false, so no need to execute then statement. You will go here directly and increment the value of A. A has a value 1 previously. 1 plus 1 is going to be 2. So now store the value 2 in variable A and see your exit condition. A equals to 10. No, A is 2. It's not 10, so this until condition becomes false. Remember, when the condition is false, you will go back to the loop again. Now it's time to do the third iteration. So look at the third value of your test data, which is 19. Let me quickly clear this all. Let's put the third value, which is 19, in variable x. Now, compare 19 with the value in variable b, which is 8, modified in previous iteration. Now, is 19 greater than 8, which is true? Since condition is true, go to then statement and assign the value of x, which is 19 in this iteration, to variable b. Since there is a change in variable b, put 19 in your trace table. Look at the next condition. Is 19 less than the value in variable c, which is 4? Since value of c is not modified, so we will take just the previous value of c. Now, is 19 less than 4? It is false. So no need to execute this condition. Go ahead and increment the value of a. Now the last value of a was 2. 2 plus 1 is going to be 3. Put 3 in your trace table and check for the exit condition. Look at here. A has a value 3. It doesn't have a value 10. So there is no need to go out of your loop. Let's do the iteration, the fourth iteration. The fourth value in your test data is 17. Let's put 17 in variable x, but before that, let me clear everything. Okay, here we go. Now putting the value 17, which is the fourth value of your test data, in variable x. Now compare 17 with the value of variable b. The last value of variable b is 19. So is 17 greater than 19? No. The condition is false. No need to execute then statement. Now compare 17 with variable c, which is 4. Is 17 less than 4? This is false again. No need to execute then statement. Next, increment the value of a. A has a previous value 3 stored in it. 3 plus 1 is going to be 4. Now put the value 4 in your trace table. And since we worked on 17, that's why also write down 17 in variable x. I have forgot to write the previous value, which is 19. Students, please do not forget to write the values, otherwise you may make any mistake. So I'm really sorry for that. I should mention the values of x accordingly. Now we worked on 17 as well. Let's quickly see the exit condition here. The value of a is 4. It is still not 10. So we will go for the next iteration. The next value of your test data, the fifth value, is 3 if you see here. Let's store the value 3 in variable x. Now, is 3 greater than the value of variable b, which is 19? No, it's not. Do not execute then statement. Compare 3 with the value in variable c. Is 3 less than variable? The value in variable c, which is 4. 3 is less than 4. It is true now. Since this condition is true, go ahead and execute then statement. Assign the value of x, which is 3 in this iteration, to variable c. Since there is a change in variable c, so you must record it. Remember to put the value 3 in variable x because we are working on we are working on the value 3 of our test data. So in the same iteration, you have to change the value of c, which is 3 now. Now quickly increment the value of a. A was 4 previously, 4 plus 1, its new value is 5. Record it in your trace table. Now, see the exit condition. A is still not 10, it is 5. Since the condition is false, you will be in the loop and go for the next iteration. The next test data value is 11. Let's work on it. Okay, I'm putting the value 11 in the variable x and also in the trace table at the same time. Now, is 11 greater than 19? Because the value of b, the last modified value, is 19. It's a false condition. Since condition is false, no need to execute then statement. Is 11 less than the value of variable c? Now look at this. In the last iteration, variable c is modified with the value 3. So let's put 3 in place of variable c. 11 less than 3, which is false. Since condition is false, no need to execute then statement. Increment the value of a quickly. Last value of a was 5. 5 plus 1 is going to be 6. Put 6 in your trace table and see the exit condition. The exit condition is still not satisfied as the value of a is 6. It is not 10. So let's go quickly for the next iteration. Look at the next value of your test data, which is 6. Let's work for 6. Putting the value 6 in the trace table and also in your pseudocode. Now, is 6 greater than 19? False. No need to execute this statement. Is 6 less than 3? No. False. No need to execute then statement. Increment the value of a. A had a previous value 6. 6 plus 1 is going to be 7. Record in your trace table and see the exit condition. A is still not 10, it is 7. So condition is false, go for the next iteration. The next value of your test data is 1. Now carefully see that. Let's put the value of in the trace table. 1 is going to be here in column of x and also put it in the pseudocode. Now let's do for the value 1. Quickly see that. Is 1 greater than the value of b, which is 19? This is false. Since condition is false, no need to execute then statement. Quickly go down. Is 1 less than the value of 3, which is, c, which is 3? 1 less than 3. Yes, 1 is less than 3. It's a true condition. Since the condition is true, go down and execute then statement, which says that put the value of x in variable c. Since variable c is modified now, so you have to change its value in the trace table. Now, go down and increment the variable a. A has initial value 7. 7 plus 1 is going to be 8. Write down 8 in the trace table and check the exit condition. The condition is still not true because a has a value 8. It doesn't have a value 10. So, quickly go for the next iteration. The next value in your test data is 13. Let's do for value 13. Let's put the value of 13 in your trace table and also in the pseudocode in variable x. Now, is 13 greater than 19, which is the value of variable b? It's false. No need to execute then statement. Is 13 less than the value of c, which is 1? You have to consider the last modified value of variable c, which is 1 in the previous iteration. The condition is again false. 13 is not less than 1. Now, no need to execute then statement. Go down, increment the value of a. A has a value 8. 8 plus 1 is 9 now. Put the value 9 in the trace table. Now look at here. The exit condition is still false because A has a value 9. It doesn't have a value 10. So what you have to do, you have to go for the next value of your test data, which is 9, and you need to be in the loop when the condition is false. So let's do for the next iteration, putting the value 9 in your trace table and also in variable x in your pseudocode. Now compare 9 with the value of variable b, which is 19. Is 9 greater than 19? No, false. No need to execute then statement. Is 9 less than 1? No, no need to execute then statement. Look at here, go down and increment the value of a, which is 9 plus 1 equals to 10. Now here, put the value of 10 in the trace table, and if you see the exit condition, a equals to 10. This time the value of a is 10. So this condition becomes true. And remember, when the until condition becomes true, there is no need to go back to the loop because this is end of your loop. You will exit your loop immediately when the exit condition or the until condition is satisfied. Now, look at here. After the end of your loop, you have to output two values. Is an output statement that is going to print the two values of the variable b and c. So look at the value of variable b in your trace table. Look at the last modified or last stored value in variable b, which is 19. Now, 19 will be displayed on your screen and the other value is for variable c. The last modified or stored value in variable c was 1. So 19 and 1 will be displayed on your screen. And it was already, I mentioned previously that B is storing the largest integer and C is storing the smallest integer value in your test data. So if the result is 19 and 1, then you can comment that the pseudo code is working without errors. It is working the way it should and fulfilling the purpose for this test data. Thank you so much. In this way, we fill the trace table by using dry run of the pseudocode. Stay tuned, stay connected, and do not forget to subscribe the channel. Bye-bye.